Hey, John here. Let's look at this algorithms library right here, okay? I'm at cppreference.com. This is their homepage. If I click on algorithms library, I see a whole bunch of interesting functions I can do all sorts of neat things with. As they mentioned at the top here, almost all of them deal with a range of elements from one of these standard template library containers, right? And this is the usual open-ended range, starting at the first element here, up to but not including the last element that's referred to by an iterator over here, okay? So what's going on in here? So let's look at these here, the non-modifying sequence operations. All of, any of, none of, for each, count, what is all this stuff, right? Let's look at this find if not, right? This is a pretty simple one to first pass. What we've got now is three functions that are all discussed on one page: find if, and find if not. These are all obviously related, so they have a lot in common. It's all in one page here. So let's run a couple of examples and see what's going on. Let's look and see what we got here. Before and after C++20, they changed it a little bit in how it's defined. This doesn't affect any of the example code that I'm going to show you here. This will work fine in both cases. This is a pretty subtle change. So what happens here? So here's the find, and here's the open-ended range. There's the first and the last element that we want to search in order from first to last. These are iterators. For the first element, we can find that has a value that equals this value parameter over here, the third argument, right? If it is found, find will return an iterator that's referencing the element in the container inside this range whose value equals the one that it's checking for here, all right? If find does not find this value in the range, it will return the value of this last iterator here, okay? Now, if you think about it, if you want to search the entire container to find some value here, you would put, container.begin to container.end, and maybe I'm searching for a value, like an element whose value equals 12 or something like that, right? So then I would put a 12 there, and bang, I'd get an iterator that points to something. And if it's not equal to this, which in that scenario would be the end, then I know I found it, okay? We find if has this unary predicate thing going on here. We'll talk about that in a minute. And find if not is simply the opposite of find if up here, okay? So let's look at the possible implementations here, right? So it says first version. This is the find. This website's kind of neat in that it gives you these little implementations. I mean, in theory, this could actually be what you get in the algorithm header file right here, okay? Now, one particular library might be optimized in some way that runs faster or something more fancier than this. But for all intents and purposes, whatever you get with your compiler will act as though it's literally implemented like this. So you can see what it's going to do. It's just going to start for loop, while the first is not equal to the last, and then iterate forward. So it's going to use first as its scanning iterator, the variable that's going to reference every element one at a time, right? So it's going to ask, is the value of the element that's referred to by the current value of first equal the thing that I'm looking for? If it does, return that iterator. If it doesn't, just keep on going. When it totally runs into the end, if it never found it anywhere, pow, we return last, okay? So let's look at an example program. So doesn't matter what kind of container, this will work on all of them. So I'm going to just use a vector of strings for this example. I'm going to fill it up with a bunch of stuff using pushback, right? So that means this vector will be filled up in the order that I see them pushed back here, A, B, C, D, E, F, G. Okay? What do I do down here? I'm going to go ahead and just print them out with a space in between each one so we can see that they're there, that I didn't make a mistake up here. Then we're going to say call the find, okay, which, by the way, is defined up here in this algorithm include file up there, right? and we are going to pass it the begin and the end. Search the entire vector from beginning and ending for the first occurrence of an element whose value is D. Okay? Let's go ahead and make this interesting and put another D down here to prove that it stops on the first one, right? We can obviously have two of them in there that have the value of D. Which one would it find? It's going to find the first one it finds starting at this position through that one, okay? When it comes back, if it found it, or rather I should say if it did not find it, right, then IT would equal whatever I told them for the end, which is the end of the whole vector. I'll print a little not found message. If it did find it, I come down here, and what do I do here? I take the iterator that find returned, and until it equals the end, I'm going to print out the elements, and I'm going to advance my iterator and then print a new line at the end. Little sloppy with the extra space over here, but it simplifies the code for this discussion, no problem. Okay, so if it finds a D, it's going to print out all the elements starting at the one it found. I know it's going to find this one here. So what will happen is that bottom loop should say, you know, I found it and here they all are. And it should say D, E, F, D, G. Okay, so let's go ahead and compile this up. And sure enough, that's what it did. It found the first instance of D in this whole range because I give it the entire range, okay? All right, so just for fun, let's mess around with that range to make sure that we're following along here. So let's put that extra D back in there. So this all matches. But what we're going to do is we're going to play with the range here, okay? Instead of going from begin to end, like we did before, let's put this one in here. Let's start at begin and only look up to begin plus 3. And for that matter, let's look for an X. There is no X. All right, it's not going to find it. So what's this going to return? This is a great quiz question example, right? What's this going to print out down here after this thing runs, right? It didn't find the X. Well, if I only search from begin to begin plus 3, it's only looking at these 3 items up here. Not only is X not there at all, it's not in the first 3. Okay, so it won't find it. Now, what's it going to return? It's going to return this. IT will be a reference to the iterator called last, which is begin plus 3. So here's the begin will be the first one, plus 3, 1, 2, 3. Okay, so what's going to happen is find will return an iterator whose value is last. Down here it will say it didn't find it because it returned an iterator whose value is this last, okay? But I removed the else in here, okay? There was an else in the last example. And it'll fall down and print from the current iterator to the end of the list no matter what anyway. So this case, it won't be found. IT will equal last, which is begin plus 3, so it's still going to print some stuff out of here, okay? So let's run that one. And sure enough, that's exactly what it did. Let's review that once real quick here. Find only scans this open-ended range, okay? So if you don't give it the end of everything, like I did here, it's going to return an iterator in the middle of the container, and there's nothing wrong with that. Maybe you only want to look in the beginning part. I now moved it back to end, so this is running like it did in find one, the first example code, but I'm still searching for a non-existent value. Now what's it going to do? Again, it obviously won't be found. IT will return the value of this parameter here, because that's what find does when it doesn't locate what it's looking for. And then what's going to happen down here? Well, the loop body won't execute because IT will equal end, because that's what I used for the last end of my range. And then it'll come down here and print this sloppy blank line down there, okay? That's exactly what it did, all right? So be careful what happens with this open-ended range if you're only scanning part of your container, it can get very confusing, especially if you do something like search for a D here, right? Let's look and see what happens here. I moved it back to only scan from first to begin plus 3, okay? So last right here is this element right there that only by pure coincidence has the value D in it right now, right? Because begin is the first one plus 3, 1, 2, 3. Last in this scenario is pointing at this D. It turns out it won't find the D because it's only going to scan these first 3. Then it's going to return last, which happens to equal D. And then down here, it'll print out the list starting with D. Massively confusing everyone if they're not paying attention, okay? So, again, if I search for X, it's still going to print out the list starting at D because I didn't tell it to look any further. So if it doesn't find what it's looking for, it's going to return this argument right there, okay? So the other thing that would be very strange would be what? If I started it in a strange place, right? I mean, again, this is variations on a theme. You can do what you want, right? Search from 3 to 6, right? Well, we already know begin plus 3 is there. 4, 5, and 6 is here. This will not be searched, okay? So if it doesn't find it, it's going to return this element right there, a reference to that one, right? And again, that's what we've got here, all right? So there can be all kinds of tricks you can play on yourself if you start playing around with these ranges and kind of forget what you're doing and start thinking in terms of the begin and the end of the whole container, when some code down here might actually only be searching, you know, a range, a sub-range within that container, okay? So let's look at this if1 thing here, all right? What happens if we call findif, right? Which is this guy up here, right? And the example down here says findif takes an open-ended range and something called a unary predicate. So what is a predicate? All right, it turns out a predicate is just a function type object that we can pass in as an argument, right? This is the address of this function right here. If you put a function name and don't put the parentheses after it, it means don't call the function, just give me the address. So that this argument is the a pointer to this function in you know, some simplest of terms here, okay? So this function has to return a bool or something that's easily converted into a bool, like an integer, right? If it returned an integer whose value is 0 for false and any non-zero integer would be true, that would also work, okay? But let's go ahead and make this example a bool. And it has to take an argument whose type here has to match the type of the container upon which you're using it as a predicate, okay? So what's going to happen is, we can quickly look at the implementation code they show us. That's this one right here. So when we give it a unary predicate called P, it's going to work a lot like it did up here when it was just saying, does it equal the value that was passed in, right? So we just looked at this one. Now we're on to this one down here. Here's findif. So what we're going to do is, rather than just saying, hey, is that element equal to something, what we're going to do is we're going to call the predicate function, and we're going to pass it the value of each element one at a time. And if that function returns a true, then we'll return the iterator that points to that particular element, the first one it found when the predicate function returned true. All right? So there's my predicate function. It'll return true if the value that's passed in is equal to a capital C or a capital D. All right? So that will apply to this open-ended range, right? And in this example, we're going to search the whole thing from beginning to end. and it'll return the first one that matches this expression up here. This function can be arbitrarily complicated, right? But we don't need to worry about that. We just want to look at the mechanics, how things are connected together here. So there's your predicate function. Here's how you call it in the findif function that returns this iterator. And just like find, if it doesn't find it, it'll return the value of this iterator here. And all the same games with the ranges and stuff apply. We don't need to go over that again. So I'm going to call this, I'm going to print some asterisks out, and then I'm going to say, if it couldn't find it, it'll say not found. And after that, it'll simply fall through and print out every element starting at the iterator through the end of the vector. Now, because last here equals vec, and if it's not found at all, there will be nothing to print, and it won't print any values out. And because of the simplicity of this loop, it'll print this gratuitous blank line at the bottom. All right, so let's go ahead and run this one. Okay, and we see it found an element that started with a C, right? Because our predicate function wants to find anything that starts with a C or a D. So let's go ahead and start searching from here. Okay? Obviously, it won't find anything. And that is what? Here's begin plus 1, 2, 3, 4. Now it won't find it because we're going to only check what? The EFG part of this vector, right? Oops, there we go. And it didn't find it. All right, so there's no, it shouldn't come as a big surprise. So you can either put a value in here and it'll compare from each one of the elements for equality, searching to find to return the first one that matches, or it can be given a function like this with a findif, and let the function decide if it matches what I'm looking for. Okay, so let's look at this guy down here. What does this one do? Well, now I have an entire class in here. But this class has an overloaded function operator that returns a bool, and it accepts a string, which is compatible with the value in this container. And I can put any kind of complexity I want in here, all right? But I kept it simple. If I construct an instance of check first character, what it's going to do, I give it an argument for the constructor, and it saves that character, okay? So this will return, what? True if the value here, the val, which is the character that's given in the constructor, a single character, if it matches the first character in this string that's passed into this class here, all right? Yeah, sure, we could have done this with the predicate function in the last example, but I just wanted to show you the mechanics of using, an instance of a class for this, and how to write the overloaded function in here to make this thing work, in case that's new to you, okay? So how then does this work? I've got a bunch of items in here with multiple character strings in them, and I'm going to print it out, and then I'm going to say search the entire thing. We don't need to play any more games with the range. You know how that works. Same game from first to last, and it'll return the first one found that matches this predicate over here. Or if it's not found, it'll return the last, okay? So what is this going to search for? It'll return true if the first character of what it's scanning for in here starts with an E, or in this case, a capital E. So if we start at the beginning and go down here, it should return the eagle. If it returns the eagle, it won't return, the copy of the last iterator argument here. So this will be false. It'll come down here and just print out the elements in the range from the first one it found through the end of the container, okay? And there you go, okay? So that's a partial key match kind of a situation. Words that start with an E, right? So, and the same thing will happen if it doesn't find what it's looking for. It'll return the, the end of the thing, and we put an X in there, right? No problem. and it's not found. It returned the end because that was the range that we gave it. All right, so you now know what predicate functions are and what they mean and kind of how they're used. You see this thematically coming up in the algorithm library over here. If we back up and we look at these other functions in here, you have count and countif, right? So we don't even need to talk about this now because you're going to already know how this works, right? So what does this thing do? It's going to return the count of things that match some condition here. Look what's going on. Count. You got an open-ended range and a value, all right? We can read the doc, but as you can see down here, it counts the elements that are equal to the given value here. Okay, that's just like find, but this one just goes through the entire range and counts them all. Down here, what do you suppose countif does? Exact same thing. We got an open-ended range, and it will count them if you give it a unary predicate, a function or a class with a function operator in it, that returns true when it's called for each of the elements in the container. All right? So thematically, I mean, with this one example, you can cover almost all the items that are described in here. Okay? They were all either for different purposes, but you can pretty much kind of figure these out. The all of, any of, none of, these are, you'll see, defined in terms of the find. Okay? All of. Give it a range and a predicate. Okay? And so on, right? Look what happens. Look at the implementations of these. Here's an example implementation of all of. Now, what does this thing do? It goes through all of them and it calls find if not. Here's another one, any of. This is probably better because we didn't talk about find if not. Maybe I should. We'll go back and touch that one in a minute. We talked about any of. And here you go. You got your range and the predicate. So what does this really mean? It's going to call find if, which we just went over, and find what? The first element in the range that P returns true on. So what does that really mean? If P returns true on anything, when it's scanning, find if will not return the last here. So if we call find if and we ask it's not equal to last, right? The iterator value that it returns. If it's not equal to last, then we know what we were looking for was found in there. And that's what any of really means. All of, any of, none of. There's another find if, right? With the opposite condition. So look up here at what these do. Oops, I passed it by. Checks if the predicate returns true for all elements in the range. That's all of. Okay? The any of is the one that we were just looking at that calls the find if, right? This thing checks to see if the predicate returns true for at least one element in this range. Right? So it should make sense. If any of the elements in the range return a true from this predicate function, then the any of function here will return a true. None of will return true if and only if none of the elements in the range that you give it down here see the unary predicate returning true. Okay? All of is a little bit different because it wants to know that every single element in the range returns the unary predicate of true, right? So if you look and see how that one works here, it calls this find if not, which is kind of like the opposite of find if. And if find if not returns last, it means that it didn't find what it's looking for in there. Okay, so let's look and see how that thing works. Find if not. It's easy enough to check. We just simply change this to not and run that example. All right, let's go back and read the doc for it real quick. Right, forgot to go and do a find if not. Bad me, bad John. So what do we got here? Find if not. Same thing, open in a range and a predicate. What does it do? Find if not, searches for an element for which the thing returns false. Find an element for which the predicate returns a false. The first one that it searches for in here, right? So let's see. If I run it the way it is, what is it going to do? I'm looking for something that starts with an X. And I'm going to start here. Does that start with an X? Nope. So that's the one it'll return. Okay? This will return apples. All right? But if I search for A, then it will match the first one. And I want to find the first one that does not match. Okay, so that should return berries. Okay, and you see that's what I did here, right? So, if we go back to where we were, oops. And remember we were looking for all of and how that thing works, right? And these all have the same overall signature, right? It's got open inner range, the predicate. And we look at the example code for the all of right here, okay? And it says, it calls the find if not for first, last, and the predicate, and it asks, does it equal last? And if you think about that for a minute, find if not will return last if every element in the range returns true from this predicate. And because we're asking, do all of the elements in this range return true from this predicate, the only time that happens is when they find if not can't find any that don't match, in which case it returns last, and this condition is then true. Okay? So if we called all of, that's how that thing would be implemented, right? So by just knowing find, right, you can then extrapolate to find if and find if not, and you can understand quite easily the all of, right? And there's a few other things in here, and they all base a little bit on each other. Count, and like I said, count if. These are counting the number of things that satisfy these predicates, right? That works just the same way, except it counts all of them instead of finds them, right? Otherwise, it would be called find. All right, so those are the non-modifying sequence operations that come in the algorithm library. So if you ever need to find anything or count things that show up in your containers, that's what these algorithms up here do. Thanks for watching. See you later.